In section 5.1, we were introduced to a system of equations. Remember, a system of equations is two or more equations with two or more variables, and they have a common solution. To find that solution, we graphed each equation and we found an intersection point. To see if that intersection point was a solution, we substituted it back in to each equation to check to make sure it made each equation true, or in other words, that the left side equaled the right side. And I know some of you are thinking, after we did that, Miss Golly, this graphing thing, is there another way to solve these systems besides graphing? And there is. Today we're going to look at our second method to solve a system of equations, and that is called substitution. With substitution, we actually have two different approaches to it. I'm going to look at the first one, method 1. Start with method 1. It says to solve for x first. What that means is, step number 1, I'm going to label each part of this. I'm going to break down the little paragraph. Solve for x in one of the equations. When we see that solve for x piece, that means we're going to get x by itself. We're going to have an equation that says x equals and then some expression. So to start off, I want to start with letter B. I want to start with letter B. And our directions say, step 1, solve for x in one of the equations. As I look at letter B, I have two different x's. I have a plain x, and then I have a 3x. A plain x is going to be easiest to get by itself versus an x with a 3 in front of it. If there's a 3 in front of the x, I know at some point to get the x by itself, I'm going to have to divide by 3. If I have just a plain x, it just has a 1 in front of it. I'm not going to have to divide by anything to get that x by itself. So what I'm going to do is I'm going to take that first equation and I'm going to get x by itself. So in order to do that, I have to take this negative 6y, the entire thing, pick it up and move it to the other side. So to move the whole thing, negative 6y, to undo that, I have to add 6y to both sides. Negative 6y, positive 6y, they're going to simplify for me. On the left side, I have just x, and I have equals. Now on the right side, I have a negative 11 and a 6y. The negative 11 does not have a y, so I cannot combine it with the 6y. Those are not like terms. So that's all I can do. So that is what is meant by step number 1. Step number 1 said get x by itself. Then step number 2. Substitute the expression for x into the other equation to find our y value. So we're going to take what x equals and substitute it into the other equation for x. So remember, we took the first equation, this was our first equation, and we solved it for x. So now we take what x equals and substitute it in for x in that second equation. So here's what that looks like. I have a 3. In place of the x, I'm going to write negative 11 plus 6y. Then I still have plus 2y equals 7. So into that second equation, instead of x, I wrote what x equals. We have to keep in mind we need to use parentheses. Now I have to solve that equation for y. So here's where our equation solving skills come in handy. First I have to distribute. We get negative 33 plus 18y. And then I still have plus 2y equals 7. Now we have the 18y and 2y are on the same side. I keep the signs the same, and I combine those like terms. So we have negative 33 plus 20y equals 7. The only time I do the opposite is when I want to move a term to the other side of the equal sign. To finish this off, we're going to add 33 to both sides. 20y equals 40. Finish off, divide by 20. We get y equals 2. So we found what our y value is, but we have two variables that we have to solve for. So now that's where step number 3 comes in. Step number 3, then substitute the value of y into one of the original equations to find x. So I'm going to take that first equation, x minus 6y equals negative 11, and I'm going to substitute what y equals in for y. When I do that, now the only variable left is x. So I have x minus 12 equals negative 11. I add my 12, and we get x equals 1. That solution, we have x is 1, y is 2. That solution would be the same thing we would get if we graphed both of those equations. And I know looking at those two equations, some of you are thinking, Miss Golly, those might not graph the nicest. And you're right. Graphing doesn't always work out very well for us. Sometimes the equations just aren't very suitable for graphing. So this idea of substituting would give us the same solution as if we were to graph those two ordered pairs. Let's try this with the second method, and really the process is the same. I know we think, Miss Golly, that's method 1, let that sink in first, but sometimes method 2 is the way to go. Method 2 is solving for y first. So the first step is solve for y in one of the equations. What that means is we need to get y by itself. Now this is something that we're a little more familiar with because we changed some equations to slope-intercept form in one of our earlier units. So I'm going to look at letter C for this method. It says we have to get y by itself. If I look at letter C's equations, I have a y in two different places. I have a y that just has a 1 in front of it, and I have a y with a negative 5 in front of it. The y with the 1 in front of it is always going to be our easier choice. To get that y by itself, we don't have to worry about dividing by any coefficients in front of it. So I'm going to take that first equation and get the y by itself. In order to do that, I have to take the negative 4x, pick up the whole thing, the positive 4x, pick up the whole thing and move it to the other side. In order to move the entire positive 4x to the other side, I have to subtract it. I need to do the opposite. Negative 4x, positive 4x, they give me the 0 I need. Now I'm left with just plain old y equals, again on that right side, I have negative 1 minus 4x. I cannot combine the negative 1 and the negative 4 because they do not both have x's. So step 1, check. We have y by itself. Step 2, substitute the expression for y into the other equation to find x. So I'm going to take this expression for y, this was from the first equation, and I'm going to substitute it in for y in the second equation. It's a y equals, so it needs to go in for y. In the first example we did, we had x equals, so we needed to substitute that in for x. So my second equation, we have 3x minus, then we have a 5 in front of the y. In place of the y, I'm going to put the negative 1 minus 4x, and it equals negative 18. Oop, I ran out of space. Hang on, guys. Negative 4x equals negative 18. There we go. So now in order to solve, we have to be careful. This 5 is really negative, so when we distribute, we have negative 5 times negative 1 is positive 5. Negative 5 times negative 4 is positive 20x. And we still have equals our negative 18. 3x, 20x, they're on the same side. Keep the sign the same. We get 23x plus 5 equals negative 18. Now it's one of our nice little two-step equations to solve. We subtract the 5. Divide by the 23. So x equals negative 1. We have our x. Once we have our x, now we move on to step 3. Substitute the value of x into one of the original equations to get y. So I'm running out of space. I've got this writing down at the bottom, so I'm going to do step 3 up above here. Into the first equation, I'm going to do step 3 up here. I have 4x. I'm going to take 4x plus y equals negative 1. I'm going to take what x equals. X was negative 1. I'm going to substitute that in for my x. So 4 times negative 1 plus y equals negative 1. Negative 4 plus y equals negative 1. Add our 4 over, and y equals 3. So we have x equals negative 1, y equals 3. So I know you might be thinking, okay, Miss Golly, there's two different methods. I get an x by itself and I substitute in, or I get a y by itself first and I substitute in. So how do I know which is which? How do I know when to do each method? So go ahead and turn to page 138. It's just the next page in your student journal. Down at the very bottom, it's asking us, number 4, to explain our choice of method. We're not going to solve each one of these. We're just going to talk about which variable would we solve for and why is that the better choice. So if we look at letter A, in letter A I need to pick out what's going to be easiest to get by itself, x or y. It is always easiest to look for coefficient of 1, or negative 1 would also be easy as well. So if I look in letter A, I see I have an x. It's just a plain x that would have a coefficient of 1. So it would be easiest to get the x by itself first. In letter B, I see a couple of different choices. You could choose the x in the top equation, or you could choose the y in the bottom equation. Either of those would be easiest to get by themselves because they have coefficients of 1. To get those by themselves, you would just have to move, in the case of the x, you just have to move the negative 2y to the other side. In the case of the y, you just have to move the 2x to the other side. In letter C, as we take a look, letter C, the y in the second equation would be easiest. So take a little pause here, take a look at D through F, and see what you think would be your choice of what to get by itself, aka solve for first. In letter D, I would choose x in the second equation. To get x by itself, all you would have to do is add 3y to the other side. You wouldn't have to do anything extra, there's no extra division. In letter E, I would choose the negative x. And now I do want to talk about in letter E. I didn't ask you to solve for these. To get that x by itself, we would add the 3y to the other side, but then I'm left with a negative x. With the negative x, there's really a negative 1 in front of there. To undo negative 1 times x, we do need to divide everything by negative 1. Dividing by negative 1, though, is a lot simpler than if we would have chose this x value and had to divide everything by 3. So we end up with x equals, and then just all of the signs change. So dividing by negative 1 just makes our signs change. It's the same thing we see in letter F. In letter F, we would want to get negative y by itself. In order to do that, we would have to move our 3x to the other side. Positive 3x minus 3x gives me 0. Then I have negative 6 minus 3x. But then to finish this off, the x is not by itself yet. I need to divide everything by negative 1. So again, when you're trying to choose, do I do method 1 or 2? Do I get x by itself or y? Look for a coefficient of 1 or negative 1. Those are going to be your easier choices to get by itself. So let's try out one more together. I'll do one for you from your assignment. Turn to page 141 in your student journal. And we'll take a look at question number 12. In question number 12, the first thing we have to choose is which variable are we going to get by itself, the x or the y. We just talked about making a good choice on this, and the best choice is going to be looking for a coefficient of 1 or negative 1. So as I look at number 12, the easiest choice I see is getting this y by itself in the second equation. It has a coefficient of negative 1. So in order to get that y by itself, we need to move 4x to the other side. In order to do that, it's a positive 4x, so we need to do the opposite, which would be minus 4x. Positive 4 and negative 4, they simplify. Now I have to be careful, I am left with a negative y, and then 4 minus 4x. I cannot put those together, they do not make a 0. They do not both have x's, I cannot combine them. Now what's left in front of that y, there's really a negative 1 there. So I need to divide by negative 1. So I have y equals negative 4 plus 4x. I need to take what y equals now. I need to take what y equals and substitute it into the other equation for the y value. This was my second equation, so I need to substitute into the first equation. So when I do that, I have 3x minus 2, and then in parentheses, I substitute what y equals. Now I need to solve my equation. When you distribute, remember that 2 is negative, when I combine the 3x and the negative 8x, I get negative 5x plus 8 equals 3. Subtract 8 from both sides. Negative 5x equals negative 5. Divide by negative 5, x equals 1. I have one of my two variables now, I need to find the other. So into either equation, I can substitute 1 for x to find my y value. I'm going to choose the second equation. And I know you might be thinking, how do you know to choose the second one? I always choose the one that I started with. So I started with the second equation to get y by itself. So I'm going to start with that same equation to find my y value again. So 4 minus y equals 4. Subtract 4 from both sides. I get negative y equals 0. You can divide by negative 1 if you need to. I get y equals 0. So x is 1, y is 0. You can still check these the same way we checked the graphing. You can substitute your ordered pair back into those original equations. If you need help checking, please ask me when you do your progress check today. I know we got a lot of practice with that in 5-1, so if you need help checking, let me know. So at this time, please grab a progress check from the shelf, try it out, check it. If you have questions, let me know. If it's okay, just check it in with me, and then you're finished for today.